Hi everyone, so today we're going to talk about apparent weight, and before we start we're going to make sure we understand these terms. So how do we calculate weight? What is the formula? So weight is always equal to m times the acceleration due to gravity, which is g on planet Earth, and it would be different on a different planet. And what is mass? So mass is actually the amount of matter in an object, and it never changes. So wherever you go, it's the same thing, and it's always measured in kilogram, or it could be, you can convert it to grams and other units. Now the question is, what is an apparent weight? So let's understand that I can step on a scale here in my room, which is located on Earth, right? And this scale will show me 120 pounds. Well, I wish, right? So, but when I go on a different planet, or let's say if I go to Moon and I step on the same scale, it would actually show a different number. And there is actually another situation that I can show you how your apparent weight would be different than your actual weight on planet Earth. So you don't actually have to travel to a different planet to measure it. So let's say if I'm standing on an elevator that's speeding up at 3 meters per second squared, and I want to find out what my apparent weight is. So since this is a force kind of problem, it deals with forces, what I'm going to do is that I'm going to start my question with my general formula, which is the sum of all F's equals ma. That is one of Newton's most important laws in Newton's physics. So what does it mean, sum of all F's? So this is sum of all the forces that is acting on this little girl in the elevator. So in order to find out what that is, let me just draw a free body diagram to actually show us what forces are acting on this person. So there's always the force of gravity that's pulling this person down. And upwards, this floor, the floor of the elevator is actually pushing back on me, opposite to the direction of force of gravity, and I call that the normal force. Well, now in this question, the normal force actually represents my apparent weight. So normal force equals my apparent weight. So what is my goal in this question? To actually find what normal force is. Now, what are the forces that are acting on this? So there are only two forces. We're neglecting friction, static friction, and everything else here because it's not in the direction of my motion. And so in the y direction, so let's say if this is the y and this is the x direction, in the y direction I have n acting plus f of g equals ma. And this acceleration would be the acceleration of elevator. Now, once I have this, I'm going to actually solve for the normal force. So if I wanted to solve for this, I'm going to keep the normal force on the left-hand side. I'm going to write ma, which is on the right-hand side. And I'm going to bring fg to the other side of the equation. So the sign will change and I will have my force of gravity on the other side. Now I just want to find out what Fg is, the force of gravity, which is equal to mg. So I'm just going to write this differently. I'm going to write ma as is, and I'm going to change this at mg, but g here is a negative entity. So if I take this to be my positive y and this is my positive x, so if g is acting downwards, therefore I will have a negative associated with it. So that's what I'm going to write. So my final equation that represents my normal force here is ma plus mg. Why? Because there's the minus and the minus multiplied together, and I will get a positive number here. Now, in order to make this a little bit more simple to look at, I can actually factor out an m and divide each term by m. So I'm going to have a plus g left. Now this is my actual general equation. This is something you want to actually remember. and you can use it for every different, elevator question. And if I were to actually plug in my numbers for this, what I'm going to write is for n equals m. M is not given in this equation. So for this question, let's say if the mass was 100 kilogram, and if I were to plug in my numbers here, I will have my normal force or my apparent weight equal to 100 kilograms. A is 3 meters per second squared plus 9.81 meters per second squared. And if I were to put this in my calculator, I would have 3 plus 9.81, 12.81 times 100. I will have my normal force equal to 1,281 newtons. So that would be my apparent weight. Now, what is my real weight here in this question? I just want to find out. So I'm just going to do this over here. My real weight would equal to mg, and that's my mass, which is 100, times 9.81, and which is equal to 981 newtons. Now, my normal force, which is my apparent weight, is much bigger than my actual weight. So this is a result of this equation, and I know that if my acceleration is a positive number, then I will always have my normal force or my apparent weight higher than my actual weight on planet Earth. So let's do a different example. In this example, let's say if the elevator is slowing down near the top at -3 meters per second squared. Same person, same elevator. How is my apparent weight different? I'm going to use the exact same formula as the previous example, and I'm going to plug everything in here. So mass would be 100 kilogram. My acceleration is -3 plus 9.81. Remember that we included the negative sign for g in when we were actually deriving the equation, so we don't have to include it again here. Therefore, my answer, if I put these numbers in a calculator, I will get 681 newtons, which is my apparent weight as the elevator is slowing down. Now, compared to my actual weight, which was 981. This one is a smaller number. So since this is a smaller number, that means if the elevator is slowing down, then my apparent weight would actually be a smaller number than my actual weight. Have the elevator moving at no acceleration. So your acceleration is at 0. So what does that mean to have a 0 acceleration? It means that you have a constant, or you're moving at a constant velocity. So that's what's happening in this elevator. It's moving up, but it's going at a constant velocity, and I'm there. And guess what? We're going to use the exact same formula. So N equals ma plus g. And in this case, what's going to happen here is that, as you can guess, my A would be 0 plus g, and it equals to mg. So my apparent weight in this situation will equal to my actual weight. For my last point here, I actually want to talk to you about free fall. So what's going to happen if this guy is free falling, and how would that happen? So let's say if this the cables that are holding the elevator kind of breaks, and this guy is going to start falling down at acceleration of 9.81. As you can see, my equation here, N equals ma plus g, and it's just going to have m 2g, so it would be 2mg. So this is going to be twice the weight, so your weight is going to be a lot heavier. So the last thing I wanted to mention in this video is the fact that, let's say if this elevator is in free fall somehow, well, let's say if you have it attached to a few cables and these are going to break. So you're going to start falling at a rate of 9.81 meters per second squared. right? So when that happens, if you actually saw something like that in real life, it would look like as this person is floating in air, so it's not on the ground anymore. And why does that happen? Is, let's say if I were to put this in an equation, so you would have G plus G, so it would be 2G times M. This would be the normal force. And if I have a force pulling me down at 9 point my mg, so at my weight, and then there's another normal force which is higher than mg, right? So my normal force would actually be higher here. Then if that happens, then it will look like as that I'm actually going to be lifted off the ground and I'm going to be going upwards. So the force is actually going to be enough to lift me up and have me free falling with the elevator.